Our learning target today is I can write equations of parallel and perpendicular lines. These two lines are parallel due to the fact that they never intersect. Also, they share the same slope, but a different y-intercept. If I look at this scenario, there are also two other types of sets of parallel lines. Ones that are horizontal, so all horizontal lines are parallel, and also all vertical lines are parallel. Remember, our vertical lines have an undefined slope, and our zero slopes are representing of our horizontal lines. As we look at perpendicular lines, these two lines always intersect at a 90-degree angle. The slopes are opposite sign and reciprocal, and all pairs of zero slope, which are our horizontal lines, intersect with an undefined slope, which is our vertical line, and they are also perpendicular. If I look at the scenario, if I wasn't sure if I could identify whether or not the lines were perpendicular or not, I could multiply the two slopes together and get a product of -1. As we identify if lines are parallel or perpendicular, we can do that with our slope, and we can do that even without graphing. So here, line A is what we call slope-intercept form. I can see the slope of 2/3. Line B and line C are in standard form, so I have to modify those, solve for y to be able to see the slope. I would solve both of these for y, which I've done here and here, and I get a slope for line B of -3/2 and a slope of line C as 2/3. The conclusion that I would make from this, after I've identified the slope of all three lines, would be that A and C are definitely parallel. A has a slope of 2/3, C has a slope of 2/3, and so I can prove that they're parallel. I can also prove that A is perpendicular to B. So if I look at A, slope of 2/3, and B, slope of -2/3, their slopes have an opposite sign, or their slopes are opposite signs and reciprocals of each other. Just like B and C. Line B has a slope of -3/2, and C has a slope of 2/3. Now we're going to also look at these scenarios. So I have two other types of lines. I have line A down below that's in point slope form, and I have line B, which just contains those 2 points. If I look at this scenario, line A, I can see the slope -1/2. In B, I need to figure out what the slope is by finding my change in y over change in x, which I've done here. Change in y is 2, change in x is 1, and when I simplify, I get 2/1, or 2. In my conclusion, what I would do is analyze those slopes. Are they the same, or are they opposite sign and reciprocal? And right now, -1/2 and 2/1 are opposite sign and reciprocals, so I can say that A is perpendicular to B. Just so you know, in all of them, I did check for perpendicular, whether or not their products of their slopes made -1, and I've done that here, here, and here, so you can take a look. We're going to go ahead and write some equations now. So here's the scenario. Write an equation of a line that passes through the point 1, 2 and is parallel to y equals -5x plus 4. What we need to do is we need to be able to pull the slope from the original equation. If I know that the two lines should be parallel, that the new line should have the exact same slope as the original. So it should have a slope of -5, which I've written here. We also know that the line has to pass through 1, 2. So what I did is I used point slope form because I do have a slope and I do have a point. I'm going to go ahead and plug my slope in of -5, my x value from my point in here, and my y value in here. And what I did is I solved for y to get slope-intercept form. So my new line would have a slope of -5 because they are parallel, same slope, and the y-intercept is 7. I'm going to show you how to check it on a graph. I plotted 1, 2, which is my ordered pair that my line has to pass through. And if my slope is -5, I would go down 5, 1, 2, 3, 4, 5, and over 1. But unfortunately, that doesn't give me my y-intercept. So what I could do is work backwards. Go up 5, 1, 2, 3, 4, 5, and over 1 to the left. And my y-intercept would be 1, 2, 3, 4, 5, 6, 7. And I can check that right here in my rule. And I would go ahead and draw my line using a straight edge, putting arrows in both directions. We're going to take a look at another scenario. How do I write an equation of a line that passes through -4, -1, and is perpendicular to the original line. So all I'm going to do is take the slope out of the original line and I'm going to change it opposite sign and reciprocal, which would be -3/4. Because I have a point, -4, -1, and a slope, I'm going to use point slope form. And when I do that, I'm going to plug -3/4 in here. I'm going to go ahead and plug in my -4 into point slope form and -1. I would go ahead and simplify and solve for y. This would now put my equation in slope-intercept form. I'm going to go ahead and check my work. So I started off here at -4, -1. I'm going to use the slope of -3/4, going down 3, 1, 2, 3, and over 4. 1, 2, 3, 4. And I'm going to double check my y-intercept. Remember, it should be -4. 1, 2, 3, 4, and it is. And I can check my work anytime using graphs. Now, I just want you to be aware, when we write equations of lines that are parallel and perpendicular, it doesn't matter what form we use, whether it's standard form, slope-intercept form, or point slope. It just depends on what the question is asking for. Just, you know, I gave you two options. I put it first in point slope, then what I did is I converted it to to slope-intercept form. What I would like you to do is to go ahead and copy these problems down and give these a try. I'm going to have you go ahead, once you've copied it, to go ahead and pause the video, and then I will show you the solutions. I'm going to move out of the way so you can copy. Okay, so now we're ready for our solutions. So in the first example, determine if the lines are parallel or perpendicular. So I have a line here, A and B. I'm going to tell you right now on line B, I can see the slope right away. It is 1/3 because it's in point slope form. In line A, I have to find the slope. If I have 2 points, I would find the change in y. So my change in y is 2. And then I would find my change in x. From -2 to 3, I'm increasing by 5. So if I look at these two, 2/5, and if I look at this slope, the conclusion that I would make for these two problems is that they wouldn't be parallel or perpendicular. They would be neither. They do intersect, but unfortunately they do not intersect at a 90-degree angle, and I know that they're not parallel because they are not the same slope. We're going to go ahead and do this next situation. Write an equation of a line for each given scenario. So parallel in this first one tells me that this should have the same slope, my new line. So my new line slope should be 2. This is the ordered pair, which I know that that new line should go through. So I'm going to make my equation y minus 3 equals 2 times x minus a -2. And remember, this 3 comes from this point here, and I know -2 would go right in here for x1. The only simplification that I'm going to make today is I'm going to do y minus 3 equals 2, and I'm going to change this double negative, the opposite of a -2, to a +2. Now remember, this right here is in point slope. If I wanted to solve for y, then I would make that into slope-intercept form. I'm going to go ahead and do the next one. Write an equation of a line that passes through 8,1 and is perpendicular to the given. Perpendicular tells me I'm going to take this slope and I'm going to change it to opposite sign and reciprocal, 3/2. What I'm going to do is plug that into my point slope form. Y minus 1, and this is where the 1's coming from, equals 3/2, and then I'm going to do x minus 8. And remember, the 8 comes from my 8 in the ordered pair. Remember, in both of these scenarios, if I wanted to, I could convert to slope-intercept form, and I can even graph to check.